Hello, we're going to do more practice with trigonometric identities. So for this one, I'd like to show you how to do the sine and cosine rule, where you just change everything into terms of sine and cosine. So we're going to do that on this side because this side is less complicated and thus more difficult to work with. So secant, the opposite of secant is cosine, which means 1 over cosine is secant. So 1 over cosine x minus, and then we're going to put this in parentheses, sine x over cosine x times sine x over 1 . So then we're just going to multiply that so that we get 1 over cosine x minus sine x squared, because we have sine x times sine x, divided by cosine x times 1 is just cosine x. So now we've got 1 minus sine x squared over cosine x and to recap that, or not recap, to remember our main identity, sine squared x plus cosine squared x equals 1, and if we subtract sine from both sides, we isolate cosine squared x equals 1 minus sine squared x, and I bring that up because we have a 1 minus sine squared x right here. So we can replace that with cosine squared x over cosine x, which is the same thing as cosine x, and cosine is the reciprocal of cosine is secant. So cosine, right now we have cosine over 1 because you can put anything over 1, and if we flip that, then we have 1 over cosine and, well, we don't have to flip, sorry. Yes, the reciprocal of cosine over 1 is 1 over cosine, but cosine over 1 equals 1 over secant x, which is what we wanted in the first place, because that's what our answer is here. And yeah, sorry. So cosine x equals 1 over secant x, and secant x equals 1 over cosine x, just to reiterate that because I did a poor job of explaining it here and then again over here. And in the past I've mentioned opposites. Opposite is not the same thing as reciprocal. Reciprocal is basically when you flip the fraction. So the denominator becomes the numerator becomes the denominator. Sorry, I just had to clear that up. I hope this was helpful.